This is plotting linear graphs, following on from our little game of battleships just the other day, and obviously plotting points on a set of axes or a Cartesian plane, which is obviously what the X and Y grid is referred to. Linear relationships or linear equations come in the standard form y equals mx plus c, as you can see there written on the screen, where m being what we call the gradient or the rise over the run, and c being called our y-intercept. So what that means is where the line actually crosses on our y-axis. And if you notice a little mistake here, I've put x and y there and there. So I'm going to change that to a y and that to an x. Looking next, we've got our first worked example, which happens to be work example 9 from the textbook, and it says, for each of the following table of values, plot a graph to represent this information. Then it says to write an equation to represent the linear relationship. So you can see this first one is relating f and g. You can see the letters being there, being f and g, that we need to actually show the relationship of on the set of axes next door, which isn't drawn very, very neatly. But what you can see is the points, first set of points being 0, 0. So it's saying that when f is 0, g is also 0. So if I was actually to highlight them, I can actually show those 2 points there go together as 0, 0. So on my set of axes, if I want to then go and plot the points, I can actually change it to make sure I can actually see what's going on. And the first point is there at 0, 0. Okay, the yellow's not working too well, so I'll change it back to black and lift the size up a little bit. And the first point is there at 0, 0. Second point is 1 and 5, so 1 on the F and 5 on the G. So if you look at my axis, I can say I go across right to the number 1 on my F axis and up 5 spots, and you'll see there's my next point. The next point being 2 and 10, so you can see there's a nice consistent increase. 3 and 15. The consistent increase is obviously what we refer to as a linear increase, which is why this is linear relationships. They're going up at the same rate. And you can see if I then go to draw my actual line through everything, it goes like that. And obviously yours will be a lot neater and with a ruler than what mine is. What we then need to do is look at how we can actually find what the relationship is between the two variables. What we're looking for is what are my, in this case, g values or my y values. What are they increasing by as my x's all go up by 1? And you can see that the increase is actually 5. So for every 1 that I go across on the f, my increase becomes 5. So in terms of looking at a relationship, what we're saying is that the value for g is going to be 5 times the value of f. Now, and then what I need to do is make sure that if I was to do so, do I have to add or subtract anything on to make sure that this rule works? And you'll notice that in my table above there, it says that, for example, when f is 2, my g has to be equal to 10. So if I subbed 2 into my equation, for f, do I get a value of 10? And the answer is yes. So in the end, I don't need to make any sort of rule changes. This here, oops, no, I won't down off, no. This rule here, g equals 5f, f is the relationship between these two. So on my graph over here, I can write that g equals 5f. Remember, the increase was 5 for every 1 increase in my f. Looking at the next part, this time what we've been given is a rule, and you'll be able to see there, if I just zoom in on the rule for a second, you'll notice there is it says that m is equal to 9n. So basically it's saying that for every m value, I can find it by taking the equivalent n and multiplying it by 9. So if I had to fill in that particular table, and I've made another copy here so that we can actually see it, then what I do is I say, okay, if I want to then go and fill, I'll change that to size 1. Okay. My n there is -3. I take it and I multiply by 9 and I get an answer of -27. I put 0 into my equation, I go 9 times 0 and I get 0. I put +3 into my equation, 9 + 3 gives me +27, and 9 sixes give me 54. So what I'm basically doing is finding again coordinate points, the first one being these ones, the next pair, the next pair, etc. Okay, so I then go and actually plot these particular points. The first one being -3, -27. So I go across to -3, down to -27, and that's approximately where that point would be. 0, 0 is my next point, 3 and positive 27, and 6 and positive 54. And you'll notice that they are going on in what we call a linear fashion. And again, I would write a neater one there. The rule we already know in this instance, m equals 9n. Now you can see that the increase there, my increase by my n's looks like they're going up by 27. As you can see, there's an increase of 27. But because my x's are going up by 3, I need to do an approximation of an equation of 27 divided by 3, which is where I get that number 9 from for my equation. So basically it's saying that for every 1 increase in n, I would get a 9 increase in my m value. Looking across here, this time we've got Lisa, who's a travel agent for an airline, receives a base wage. Okay, so the most important thing is she gets this much money, which I've just crossed off, but it's $160 each week. And then also she gets $40 for each flight ticket that she sells. So if we have to go and fill in a particular table here, what it says is the following. Number of tickets that she sells in a week, so it could be from 0 up to 5 as an example. How much money does she collect? Well, we know she gets $160 no matter what. So if she has a week where she sells absolutely no airline tickets, she still makes $160. If she sells 1 airline ticket, she adds another 40 to her 160, and you can see that she gets 200. Obviously she goes up by another 40, so on and so forth, adding 40 for every extra ticket that she sells. And again, what we're creating then are coordinate points that we can plot on a particular graph. So if I move to the next slide, you can see there that we can actually start plotting the points that we were referring to. So the first one that we had for her was 0 and 160. So if I'm plotting 0 and 160 according to my graph, which isn't brilliant, there's the first point. I might drop that size down a little bit. So we'll keep going down to about maybe 5. Okay, 0 and 160. Then we've got 1 and 200, and you'll see that it goes along. 2 and 240, and basically what's happening is we're going up to eventually we're getting to 4 and 320, so I haven't done that real well yet. I'll rub off some of these so my scale gets a bit better, like so, and 5 being 360, which sits approximately there. Now I've got a lot of scale here so that I can actually see things, and I'll zoom it out a little bit. You'll notice that the reason why I did that is the question on the thing said, what if she sold 12 tickets and how much did she earn that week? What we've got to do is we've got to work out what the relationship actually is. Now in terms of finding the relationship, what I can actually do is say the following. We know that her wage is going to be equal to $160 base, no matter what. And they're going to add to that $40 for every single ticket that she sells. And I'll say T for ticket, or sorry, it's D, isn't it, down there for weeks, but T for ticket. So that's what we call the linear relationship. So for every ticket, you multiply it by 40, so for 2 tickets, you multiply by 40, you get 80, you add the 160, and you end up with 240, which we saw before on our table for 2 being 240. She says 12, so I take it down. We want to know what 12 is. 160 plus 40 times 12 equals 160 plus, what's 40 times 12? It's 480. We're getting a total of $640 is her earnings for 12. Now remember, these answers are actually coordinate points, so I could actually plot it as 12, 640 in terms of that. So I go to my axes and I mark it 12, and 640 sits almost on that W up here, but you'll notice that it's in the exact same straight line as what I had before. Now, what I do want you to remember is that I do not go past here on these ones. Because this is talking a real life problem, we're talking real weeks and everything else, you can't have a negative number of weeks. Okay, so we actually make sure we stop it. Our line doesn't go past there. I still have the arrow on this end of the line up here to show that it's going in that direction more. And again, I write the rule down, which we've just written the rule. You can sort of see it there anyway, that wage is equal to 160 plus 40t. And that's all there is.